This is part 2, the double replacement reaction, and in the previous video I took your sentence equation here and showed you how to convert it into a formula equation, and we stopped there. And so what we need to do is we need to fix this, because right now this is simply a skeleton equation, meaning that you have these blanks here and these are where your coefficients go, and it's incorrect. It is not balanced. So what we need to do is we need to make sure that we have the same number of elements and ions that is on one side of the equation has to equal the same number on the other side. So if you missed how to convert this, go ahead and check out the previous video that I did on this using the same equation, and come on back after that. So what we need to do is we need to start off with, and we need to draw a line that separates your two equations here. So you need to draw a line that separates your reactant side of the equation from your product side. And what we're going to do is we are going to list everything that is occurring in this reaction. So I'm going to start off with lead. So we have Pb. And because it happened first, occurred first. And so we have lead to nitrate. And notice here, I'm going to show you a little shortcut that you can take. So we have nitrate on this side of the equation, and notice how it stays together on this side. So you have nitrate here and nitrate here. So because this polyatomic ion is not breaking apart, we can count that as one piece. So I'm going to write nitrate here. Now, if you do not want to do that, if you want to list your nitrogen and then your oxygen, you can do that. You will get the same answer that I'm going to get at the end. It's just a quick little shortcut that you can take. Then we have potassium, followed by iodide. And I'm going to list these elements and ions in the same order on the product side, so that when I go to count these, it's going to make comparing easier. So I'm going to write lead, nitrate, potassium, and iodide. All right, so now what we want to do is we are going to compare both sides of the equation. So I'm going to cover this guy up because I don't want to think about it yet. So I'm just going to look at my reactant side of the equation and I'm going to count. So how many leads do we have? If you look, there is no number written after that. That means it is an understood one. If you think about your math class, if you said that was 0, if you multiply anything by 0, you would get 0. So it is an understood one. That means we have one lead. Look at your nitrates. Remember, we're counting that as one piece. Look at the parentheses. In math, if you saw 2 parentheses 1, you would know that you multiplied. We're doing the same thing here. 2 times 1 nitrate is 2. Understood 1 potassium, understood 1 iodide. Okay? So we are done with the reactant side. Now let's take a look at the product side. So I'm going to cover this side up and I'm just going to look at this side. Again, so look at our lead, understood 1 there. That 2 is associated with the iodide, not your lead. We have 1 lead. Okay, remember nitrates, you can keep that. Imagine that there's a bracket there. There's 1 of those. Potassium, again, understood 1. And iodide, we have 2. That's the subscript 2. It means we have 2 iodides attached to there. All right. Now what we can do is we can compare both sides of our formula here. So compare leads to leads. We have 1 lead, 1 lead. Okay, leads are balanced. Look at your nitrates. You have 2 nitrates on your reactant side, and we only have 1 under products. Your nitrates are not balanced. Looking at your potassiums, 1 in the reactant, 1 in the product. Those are good. Look at your iodides. 1 in the reactant, 2 on the product. So both of our iodides and our nitrates are not balanced here. Now, it does not matter who you try to balance first. But as a rule, I typically try to balance oxygens and hydrogens last. Sometimes it can be a little tricky, and oftentimes if you balance everything else, they will balance themselves out. So I'm going to start with the iodides here. So since we have 2 on the reactant side and we only have 1 here, I'm going to put a 2 in this little blank. Remember, these are your coefficients. These are the only numbers you can change. You cannot add a 2 here where a subscript would go. That does not exist. The only thing you can change are the coefficients. But by changing this coefficient, I have to change everything in my chart. And notice here that even though I only wanted to change my iodides, so I'm going to go and change that to 2, in the process, I also changed my potassiums. So I'm going to mark that out and change those to 2. I now have 2 iodides and 2 potassiums. Again, multiply them through. So if you take a look down here, my iodides are balanced, but now my potassiums are off and my nitrates are off. So I'm going to go and try to fix my potassiums. So I'm going to go to this side of the equation. I have 2 on the reactant side. I'm going to go to my product side, and I'm going to change this coefficient here. These are understood 1s until we change them. So I'm going to put a 2 here, and I'm going to immediately go down to my chart, and I'm going to change. I changed my potassiums, but look, in changing the potassiums, we also changed our nitrates. Multiply that through. 2 times 1 nitrate is 2. And look what we did. In the process of fixing our potassiums, we fixed our nitrates. So the final step you should do is go back and make sure everybody's balanced. Lead's 1,1 balanced, nitrates 2,2, potassiums 2,2, iodides 2,2. We are balanced now. This is now correct. These are understood 1s. You can leave them like that. You do not have to put anything there. It's an understood 1. I hope that you found this tutorial helpful.
Please check out my video on the reaction between lead-2 nitrate and potassium iodide, and to have me work or perform specific chemical reactions, list them in the comments below.